Hello, this is Carrie Sundra with Alpenglow Industries, and I think it's a schematic Sunday or something like that. All right, so I thought I would share with you the FUnicorn schematic today, and we have an FUnicorn board right over here. So page one of the schematic is mostly power, and you can see that there are three different power sources here for the FUnicorn, and they're all diode protected, so if you accidentally have two of them in at the same time, they won't blow each other up. Very nice. So one power source is from the USB connector. That'll be 5 volts. The other power source can be through the optional ISP connector that is not populated by default, but that is a connector that you can use to reprogram the Atmega 328P chip directly. And this third power source is, I'm calling it 9-volt battery, but it's really just the barrel jack. And this power converter is actually good from like 3 volts to 17 volts. It is a buck converter though, so you need to give it a voltage that is over 3.3, which is the operating voltage of this power converter. So 5 volts is a pretty good voltage to give it, but you can also plug in a 9-volt battery, or you could plug in a 5-volt wall wart right here, or a 9-volt wall wart, or even a 12-volt wall wart. So a lot of different options for powering the FUnicorn. So all of these different power sources get diode ORed together, and they're called VIN here. And then VIN goes through this buck converter, which is a 500 milliamp buck converter, and it generates 3.3 volts on its output. And that's the main voltage rail that is powering the Atmega 328P. This is a little different from a regular Arduino. Regular Arduinos are powered by 5 volts, and all of their signal I/O is 5 volts. So you'll notice that since we're powering this at 3.3 volts, that means all of the output signals are 3.3 volts. And that's also why we have it written we have it written right there, 3.3 volt signals only, all of these guys. So on this one I have soldered on these optional Arduino Shield connectors, and this is the ISP connector that I was talking about. So it's basically a programming connector. All right. So then we have these 3 power converters here. They're just low dropout converters. This one is a switching converter, so it's pretty efficient. And these guys are put here because they basically power each bank of LEDs. So this guy powers the entire bank of the fuck LEDs here. And then this guy powers the entire bank of U LEDs here. And then this guy powers the entire bank of the bang LEDs. Bang is an alternate word for an exclamation point. Yes, that is a real thing. It is also very funny in this context. So therefore, we call it the bang on the FUnicorn. So that's the exclamation mark. And yeah, so all 3 of those are basically like one, they're each controlled by one output. So you cannot light up the individual lights, the individual LEDs in each word. Yeah, so you can't do any sequencing there. Sorry, there are a lot of LEDs, so kind of had to simplify it here because we don't have that many outputs on the Atmega processor. The other thing that is on this page of the schematic is the USB to serial bridge. Using the Silicon Labs one, it's really nice. It has drivers that are free for you to use, that automatically install in Windows 10, so it will show up as a in your Windows device manager as a Silicon Labs USB to serial bridge. And so we are giving it, so yes, 5 volts goes in here, and then there are some capacitors off of that. It actually outputs 3.3 volts, but it doesn't output it with enough current that we could use it to drive all of these LEDs. So, so it's used internally in this chip, but that's about it. We also have right here is ESD protection for these signals that are coming in from the USB connector. And that's just a little nice to have in case you have static charge built up on you and you touch the USB connector. Hopefully you won't sort your board. Oh, and then these two LEDs are just traffic monitors, so they'll like light up when there's receive and transmit traffic going back and forth on the USB bus. They are separate pins. They are not actually dangling off of the data lines themselves. The data lines themselves are right here. All right, and now we will go to the next page of schematic. Sorry about the size of this one. This one is on a B-sized sheet actually. So we'll zoom in here a little bit and make it a little bit easier to see. So the first piece is right here. This is the main processor. It's the Atmega 328P, same one that's on an Arduino Uno. And we have RX and TX coming in here. We have the line that goes, that comes in from the button. It's a button input. Reset line that goes out to the button, the small blue button that's on the back side of the board, which is right there. And this right here is the Atmega 328P, that chip. And then we have an input coming in from the Unicorn's leg. So that is coming in from right here. If you can, you won't be able to see it on this video, but you can see it on an actual board. There's a little via going through there. That's this like little dog leg part of the leg. And then there's also a cap touch input coming in also off of the Unicorn. And that, you can see there's a via like right there, but it's this entire Unicorn body that acts as a capacitive touch button. And let's see, there's a crystal that's, you know, making our nice clock for this processor. There is the LED that is on the button. This is an output. So this button input and output are for the button kit, which is a little bit of an add-on for the FUnicorn. It is, I can have one right here that I can show you actually. It allows you to add our big red button kit to the FUnicorn, and so that you can just push the button and the Unicorn will light up. The button also enables a very low power mode because the processor can be put into a very low power sleep mode in between button presses and just wake up on button presses. So if you want to run it off of battery power, that is definitely the best mode to put it in. And then let's see, what else do we have? We have outputs. These are outputs that control those banks of LEDs, the bang and the U and the fuck. And then we have just a normal LED that's hanging off of the processor. You can use that for, you know, doing kind of like a little heartbeat to make sure that your processor is running. And then we have programming lines with the MISO, the MOSI. And I think that is about it there. So let's see if I can go over here. This is just the shield connector. So those are all the signals going out here to these connectors on the shield. You will notice that, you know, some of these are hardwired into the board. So you know, the pins that are used for fuck and for U and for bang, you're not going to be able to really use them for much else if you want to program your Arduino, because they're going to go to the power converters that light up those lights. Same for the capacitive touch in and the leg input. The leg input, you could probably set it up as capacitive touch, but we have some code that sets it up as a resistive touch button, just to kind of, you know, show different examples of touch activated buttons. So the idea there is the very hoof down here is actually a ground pad, And so if you have it in resistive, if you have the resistive touch code in, then you can basically touch your finger across the leg here and the hoof like this, and the message will light up. And then for the capacitive touch, if you have it in capacitive touch mode, you touch the unicorn here and the message will light up. Okay, so back to the schematic. That's everything going in the Arduino Shield connectors. And then this is kind of all of our I.O. This is the resistive touch button circuit. You'll notice that all of this I.O. also has some ESD protection on it. And that was just because I felt like, you know, with something where you are actually encouraging people to touch your circuit board, it's probably a good idea to just have a little ESD protection in there so that if you shock your processor again, it hopefully will not die. So that's all that's happening there, is that that you have a diode network hanging off of here so that it shuttles energy to the 3.3 volt and ground rails instead of to your processor pin. So this is actually going into your leg. This resistor is just there again as part of the ESD network. Just helps reduce the current there if you do have a really high voltage input there by accident. It is tied high so that when you bridge again with your finger between the leg and ground, then it'll go low and that'll activate the LEDs. Capacitive touch button, same sort of thing going on here, except that there's no resistor tying it high because it's using the internal circuitry of the Atmega 328P in order to vary the voltage on that pin and read it, and therefore see if your finger is on it or not. That's using a separate capacitive touch library, and there's more information on that in the code. It's a very nice third-party library that allows you to just quickly do, you know, little basic capacitive touch buttons. So this is just an auxiliary input, and that just goes to the Arduino Shield connector, just protected because why not? And then this is actually the horn LED, which is one more LED that's separate. So it is right up here, and it's a little bit different. It's not going through any of those 2.5 volt power converters because it is being directly powered off of 3.3 volts because that LED has a little bit higher of a forward voltage drop, and so 2.5 volts wasn't going to be quite good enough for it. So it needed the full 3.3 volts, and this just basically switches the ground on that so that we can PWM that line and like kind of make it glow and stuff. So that is this is the line that is coming out from the processor, controls the transistor that then attaches ground to the LED horn LED. And let's see, then we have the big red button. So that's the big red button circuit. There are 4 lines going out to that connector. Again, some ESD diode protection. And we have 1 line for the LED. Well, we have two lines for the LED and 2 lines for the button. So this is the button output. The button is pulled high. When the button is pressed, then basically pins 3 and 4 are shorted together, so it gets pulled low to ground. Then on the LED, 3.3 volts is kind of permanently attached to the LED, and we're just driving that LED directly from the processor. That's what that BRB LED signal is. All right, and then we have just a little bit of programming and reset circuit. This is so you can, you know, hook up a variety of programmers to it as well. There's also, for this programming circuit, so one thing is that there are two basically different types of programmers that you can use to program Arduinos. Uh, one style is a 5-volt based programmer where you can actually supply your board with 5 volts through the programmer. And that's kind of nice because you don't have to have a separate power supply when you're initially programming the board. So, but again, since our processor is actually running off of 3.3 volts, it would not be good to hook up 5-volt signals there directly to it. And so that is what this little diode and resistor networks are on either side. It's just 5-volt programming tolerance for it. MISO can go directly in because it is the output from our processor to the programmer board. So it's going to be at 3.3 volts. And then this thing here, basically it allows you to use either of those styles of programmers. So the one style of programmer, you can actually power the board. The other style of programmer, which is kind of the Atmel branded ones, they don't power the board. They want to sense the board power on that pin. And that's because they have like internal voltage shifting and stuff like that. So they want to sense the power that your board is being powered at, and then they adjust the I/O levels accordingly. So this diode basically allows you to use an unpowered programmer, and so 3.3 volts will actually go through that diode to your programmer pin, and then your programmer can actually sense the voltage on the board. There will be a little bit of a diode drop there, but it's not big enough to get in the way of anything. I think that is pretty much it. Yep, LED button, unicorn horn button, or unicorn horn LED. Oh, I'm sorry, I think I misspoke earlier. So the big red button LED isn't coming straight from the processor. It's actually going through this little transistor. But you can still, PWM it with a processor pin. So it's just that the processor pin doesn't have to supply all of the current for that LED. Cool. So we'll zoom back out here. The next few pages are just a lot of LEDs. So all of these LEDs are the ones that were used to spell out fuck, and they're all being powered off of one of the 2.5 volt power converters. And you can actually see here, so these here are the 3 power converters. This is the one that is powering the fuck LEDs, which are on the opposite side here, and these are all the resistor networks here that are all our 270 ohm resistors. And then going down, so those are all the LEDs that spell out U, and got the same thing going on here. Resistor networks on the back. This guy is the power converter that is supplying 2.5 volts. And then we have the same thing here with the bang, and that's that power converter there, and it's just supplying the bang. And so this is actually the little circuit for our special unicorn horn LED, the one that's right up there. It's this really cool color of LED. It's a cyan LED, which is kind of unusual. And I just liked it. It was this great, like, light blue-white color that just, like, made it look a little bit more magical and unusual, and I just thought that a unicorn horn should be kind of magical and unusual. So, but yeah, I think its forward voltage drop is around 3 volts, so that's why it's powered directly off of the 3.3 volt power supply. And that is basically it. So why the heck did I choose to kind of do all this stuff with power supplies? Oh, I guess the one other piece of information here is that, So these processor output lines are actually that control the fuck you and bang LEDs are actually going to the enable pin on each of those power converters. So I did this design originally as a white elephant gift, and uh, I I was very last minute and I didn't have a lot of time, and so I like threw the schematic together in like 2 nights or something, and designed the whole board, and off it went. So I was basically looking for an easy way of doing things, and it seemed to me like the easiest way of turning a whole bunch of LEDs off was to just like use a power converter that had an enable pin, and turn the power converter on and off. And I wasn't exactly sure if it would work with the whole PWM scheme to like dim the LEDs or not, because the power converter takes a little bit of time to start up, and I didn't know if that was going to be an issue, but it turns out it's really not. It works really, really well. So yeah, those enable lines are being PWM'd to get that nice pulsing turn on and turn off. And they can also just be like fully turned on and fully turned off if you want just like the really solid kind of a blank. Um, what else? I could have had the Arduino running off of 5 volts instead of 3.3, but I liked having this 3.3 volt rail in the middle, because I don't know, for a few reasons. It's a little bit lower power, so the sleep mode would last longer, and I kind of liked that idea for having it be button actuated and battery powered. I liked the idea of pulling less current and having the batteries last longer, and also like I didn't want those linear converters to be dropping too much voltage. So if this was 5 volts, then they would be dropping 2.5 volts each, and that would be a lot of power wasted when the LEDs were on and off. Here, these linears are only dropping like what, 0.8 volts, so it's just a lot less wasted power. The red LEDs still are they're 1.8 to 2 volt kind of forward voltage, so there's still about a half volt of overhead that all of those resistors are dissipating. All of these resistors. Um, so all in all, it's not too bad. I feel for like a 2-day design. It wasn't Arduino compatible at that point though. I came back and made it fully Arduino compatible, and that took a little bit longer. But yeah, I mean, there are a lot of other ways that you could have done this. You know, could have just like used a transistor to kind of power all of those, to turn on and off all of those LEDs. But I don't know. This way, it kind of broke up the power dissipation, which I liked, and works pretty well. So I think that's about it. Let me know in the comments if you have any questions, and please subscribe to our channel. We're just starting out, and it would be cool to have more subscribers. And yeah, we'll do more schematics with other stuff. Cool. Thanks a lot. Bye.